So this is actually my fault, but it's actually easier for you to do the change on your side. Let me say that precisely. When you try to make the submission, which is now open, there will be some renaming you have to do, okay? So I will tell you exactly what a renaming is. If you, first of all, go back to your instruction there, what I told you about the two diagrams, something.xml, something.pdf, right? I want you to just do some renaming for me before you submit. I'll tell you exactly what it is. First of all, if you go to the instruction there, let me just go there, and then remember in the last page, there is something there to tell you what the expected directory structure is, which the program will check when you first submit. I want you to do some renaming for me, okay, on your side. If you go to the last page over there, you will see that over here I said it should be EECS3311 underscore lab underscore 1 underscore bound.pdf, right? I want you to take out the middle underscore. So this is what you have to do. EECS3311 lab 1 underscore bound. Okay, I'll write it down and then I'll show you on the screen. EECS3311 underscore, yeah, I'm gonna show you, I'm gonna copy that first, right? On.pdf, yeah, I'm gonna show you now. So this is the file I would like you to rename. So basically there's no underscore between lab and 1. Just rename that, otherwise it will be rejected by the submission, please. Yes?
Same for the XML or?
Exactly, same for XML. I'm just about to write it. The same idea, .xml. I didn't set it correctly when I put it up today, so please do the renaming for me. If I actually do the correction on my side, I'm gonna discard all the submissions, right? It's more costly. So please do the renaming and resubmit again. The submission is open now, so you can start submitting after you do the renaming for PDF and XML. Okay. So the due date, don't forget, is Friday noon. Okay? Don't forget. Okay, so let's now get started with the topics today. I want to continue from where we left about generics. Let's just review the small problem that we had. I'm going to revisit generic parameter again when we talk about inheritance. But for now, let's get some intuition about why generic parameter can be a good idea. Let's see the stack example we saw last time once more and see what we can do. Okay? We kind of did it in a rush last time. So now let's review this class over here again. So we are trying to do a stack of strings, which means every element in the stack is a string only, pretty much like in an array. So the type of all the elements must be the same. So now let's say we are trying to do some implementation. You should be very familiar from lab number 1. We're just using an array. An array should store strings only for this stack of strings. And then we have some integer I for the counter, right? It's like a pointer to tell you where the top is in the stack. You might have done something like this in 2011. Okay, and then I want you to pay attention to what I highlight in yellow. That's really the key. And then we have a count, which means the size of the stack, which is just integer. And we have a top. We want to peek what's the top in the stack, which is also string. And we want to push some new string into the stack. We want to pop. And it's just a command, doesn't return anything. So now I want you to pay very careful attention to this particular stack class. We call such a class a collection class. So collection simply means you got to store a set of things. So let's say in Java you got array list, you got linked list, you got hash table. All these classes are collection classes. You just store a bunch of elements. Now stack is just like a special case, first in, last out. So now, let's think about what's the disadvantage for this, right? So for now, the good thing is, it's very obvious we are just doing a stack of strings. Everything is string, especially the part I highlight. What's really not so efficient about this is, if you want to judge if a design is good or bad, always think about change. Now, what about today I change my mind? I don't want to have a stack of strings. I want to have a stack of accounts, let's say, bank account. Or tomorrow, I want to do a stack of integers. And next week, I want to do a stack of maybe person, right? So the type of the stack can always change. Just for this current class, do you think this will work if I want to store a stack of account? Just by using this definition. It wouldn't work, right? Because it stores strings only. Everything is relative to the string type. Okay, let's keep that in mind. And also one thing you also want to notice is, you see, somehow the type of the stack over here is irrelevant. It doesn't quite matter if that's really a string or an account over here. Because if you look at the way we implement the things, for example, let's say for the top, we simply return the last elements that's being pointed to by the counter I. Does it really matter if that's a string or a count? Doesn't matter. We simply just return the last position of the array. It's relative to the position, not really to the type of the elements. Another example here, let's say we want to push over here, and also we simply just replace the last elements by some new value. Does it really matter what type of the last element it is? It doesn't matter. It can be a count, can be a string. So over here, here are 2 points. First of all, even though we are storing a stack of strings, but we are not really calling any string-specific methods or feature. For example, for string, you can do char add, you can do append, you can do prepend, but we are not really depending on those features. So it's like you can easily change from string into account, or from account into integer for the collection. Now the second question is even more important. Think about extensibility of this idea here. You want to make sure every time you want to extend your software, you don't create too much duplicates. Let's try. Now, can you imagine how the code is going to look like if now I want to have a stack of account, bank account? Do you think the code is going to be very similar or completely different? Similar, right? What would you have to change? Yes? Exactly. Basically, everything I highlight in yellow. That's kind of like a hint. Maybe you didn't notice that. So we have to basically change everything that's highlighted in yellow, which means the type of the elements from string into account. Let's just see that. First of all, I just called it account stack. And now the array is going to store account rather than string. And then count will still be size, never changes. Now the top of the stack will be account, not string anymore, because the element type has been changed. And the push will take account rather than string. And the pop, just the same as before. Again, you can see basically that we are repeating the code structure over here, except that the type of the elements in the stack is changing from string into account. Are we okay so far with this observation here? Okay? Again, over here, the type of the elements being account is really not the main issue here, because it doesn't really matter. We simply just return the last elements whenever we do pop, whenever we do top. We simply replace the, simply just push, insert the last elements whenever we are trying to do a push. So the type of the element here is really not the issue. It doesn't really matter, okay? So now, again, we are not really doing any deposit or withdrawal. So these features are specific to account, but we are not using them at all. So now, here comes the issue. Let's say I got 10 different stacks I want you to do. I want to do stack of A, stack of B, stack of C, 10 different types. Are you really going to copy and paste the code for 10 times and then simply just replace the type accordingly? That's not the way to do. Remember we said you don't want your code or design to smell. You don't want to have duplicates. So now we have a much better idea, which is to say, think about what I said here. What I said here was, if you compare the two designs over here, account or string, the type here really doesn't matter. We can somehow delay the decision of the type later. For now, for definition purpose on the supplier side, we simply say, let's say the type is simply G or H, some letter over there. And then we can let whoever wants to use a stack to decide what kind of stack they want. And the code is going to be always the same code. Okay? Let's see how it looks like. So now we talk about generic parameter. So now so to put it more academically, we parameterize the type of the stack as G. And G here simply means just any type. Any type can replace G. It can be person, can be account, can be string. So now let's say we have stack of G, and the syntax is you have square brackets here. But in Java, maybe you have noted it's angle brackets, right? The same idea here. So now we're saying that we are defining a stack of type G, and G here is still unknown. We don't have to decide right now. We don't have to commit. Only the clients, when they want to use the stack, they have to commit, only at that point. Let's see how the rest is going to look like. So now, rather than having an array of string or an array of account, we simply say G. Everything here is relative to the G over here. Okay, we'll see that in just a moment. And then we have also count as before, and we have G, top, which will return whatever G is. And then push, which will push some new elements of type G, and etc. So far so good? Okay. Let me show you maybe on the notes, because somehow the idea will be a little bit clearer. Let me go back to the iPad notes, and let's see how this works. Let me add a new page. Okay, so now let me just briefly tell you what the signature is. First of all, this is what we did. We say class, and then we have stack of G. And then we have, for example, over here, we have, let's say, implementation, and this is exported to none. So we have imp, which is an array of G. And then we have some public feature here. I'll just do push and pop. And then over here, this one here, just nothing. We export it to everything, basically, it's public. And over here, let's do, for example, we say push, which is a command. And then we'll say v of type G. And I'll leave the rest, the implementation. Let's do also top over here, which also returns something of type G. And you also got pop. Okay, that's kind of the signature. We don't show any implementation here. So now I want you to look at, first of all, we declare the type of elements of this stack to be G. And then inside the implementation for this class over here, whenever we talk about G, for example, here, here, and here, all the green ones over there are relative to how you instantiate yellow one. Okay? For example, as soon as the yellow one is instantiated into person, every green one will be person. Okay? Let me show you how this is going to happen. Okay, this is the supplier code, let's say. So this is supplier side. This is where you define the collection class. Let's have some clients over here on the right-hand side. Let's say in the client over here, you have some local variable declaration here. Let's say I want to declare something like this. I say I want to have stack of account, SA, of type stack of account. So this is how I use it. Remember what I said before, when we define the stack, we don't have to commit just yet what the type of the stack should be. But when this client, when they want to use a stack, they have to commit to say what exactly the element is I'm going to store. Let me give you another example here. Also stack of string. Stack over here, I can put string. Okay, let's see what's the effect of doing this. Essentially, let me use different color here to show you. Let's say as soon as I have this line of declaration over here, the compiler is going to say, the compiler is going to create a copy of the original stack code, okay? And then it's going to replace every occurrence of G by account. For example, over here, you can see this here. So this is an instantiation of G. For example, let's say that means we're going to replace G over here by account. Not only that, every occurrence of G in this generic class has to be replaced by account. So which means we're going to use an array of account to store. And the push means we can only accept an account to be pushed into the stack. Similarly, the G here means the top of this particular stack called SA. The top element must be of type account. This is one particular instantiation. Of course, every time when the client decides to declare a particular version of stack, you basically create another version. So the number of possible types of the stack is really unlimited, right? Let's do another example. Let's over here, let's say I use blue. Now, over here, let's say we have a second line over here. Now, we are trying to instantiate G into a different type right now. It's instantiated into stack. Okay? I'll just say just another instantiation. Instantiation of G. Just another one. So what it would do would be something very similar. So now the G here will be replaced by just string, which means we are really having a stack of string. Everything that's stored in the stack will be a string. Accordingly, we're going to use an array of string to implement this particular stack under the hood. And then whenever we want to push to this particular stack SS, it has to be a value of type string. And whenever we want to pick the top of the stack for SS, it will be of type string accordingly. Okay? Is it clear so far? Okay? If this is clear to you, let's do some little test to see how this can help us. Okay? So what's really important for you to note, in the supplier side, let me just highlight it again. So this is the supplier side. In the supplier side, you only use just a single unknown variable called G. And G essentially parameterizes the type of the stack elements. That's on the supplier side. It's simply unknown. On the client side, they have to commit. They have to say, for this particular variable, I have to say it has to be a known type. In this case, it can be either a count, string, or any other. Yes? Exactly. I will show you just a moment. Can I just delay that just for a bit? So the question was, can you have more than one generic parameter for your class? Definitely you can. I'll give you one example verbally right away, and I'll show you how you do that. Okay? Let's say hash table. Remember hash table? Or map. Well, you learned in 2011. Let's talk about the map ADT. For map ADT, you got keys and you got values. And the keys can be any type. For example, you might have a map from person into account. You might have a map from string into person, right? Something like that. So so now here we got two parameters, G and H. The only convention you might notice a little bit weird. I wouldn't say weird, just a bit unique in iPhone. In Java, the parameter type usually is E, F, etc. But for iPhone, starting with G, H, I, J, K, right? Just some convention here. Okay. So basically the name of the parameter, it can be anything. It can be G, it can be H. However, it's a very common mistake. The parameter name here cannot be, for example, account, because account has been used as a class name already. So it cannot be a parameter name. Okay? So now, let me just show some code and I'll go back to Sa's question, just about how you can do two parameters. Yeah? There will be a tutorial and will be some example I can show you a little bit later. Okay? Let's just go back. Let's do some code checking. Somehow the information about committing to a particular type for the G helps the compiler a lot. Now let me show you how it is the case. Okay, so now, okay, you can see that's exactly what I did, so that's just on the slides. Okay, I'm gonna skip these two slides. Now let's do some compilation by our mind, okay? Let's say we got SS and SA as I wrote before in the iPad, right? So again, SS stores a stack of strings. SA stores a stack of account. So these two stacks are completely independent. However, what they are really in common is they are sharing the same skeleton of code, like a stack of G. One case, we instantiate G to be string. In the other case, we instantiate GE to be account. Okay? Now let's have a look. Let's say we also got two other variables, a string and account. Now, line number 6, can I do this or not? I say ss.push A. That's right? Okay, so anybody can justify to me why it is the case. Yes?
Because the implementation of stack for SS, no except string as a parameter.
Yeah.
So then the A is considered a string in this instance.
Exactly. So basically what you're saying is the line number 6 is valid because in line number 3, part 1 over there, we say SS should be a stack of string. Let me just make it even more explicit for you. The reason that line number 6 is valid is, let's just go back to iPad note very quickly. You can see SS over here basically is going to be string, 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 and string. Okay? Good. Okay? Now, can we do SS.push, and then I'm creating some account object and push that into it? Can I do this or not? Anyone? I heard no. Go ahead. Yes. No. Why not?
Unless it comes somehow merged with string representation, which is not in the scope of this course.
But they are not. Let's say string and account, they're completely independent.
Right. Account that means read an account object, and you're trying to push an account object as a string.
Yeah, where string is expected, right? Good. So now let me just also make this explicit to you. So now you can see that over here we're trying to say SS.push. But remember the version of code that SS corresponds to. Let me show you here. Let's go back to iPad. The version that it corresponds to is the push here is expecting string only. Right? That's why it's not valid. Now. Huh? Yes. Yes, it should be push. Yes. Thank you. Yeah, PUSH. Yes. Of course, it wouldn't compile because it's spelled wrong, right? Okay. But let's not worry about that. Okay. Yeah. Pretend it's spelled right. How about this one here? This one is somehow similar. I'm saying that SS.top. SS.top in the generic version there is going to return G. Now, I'm asking if I say SS.top, is it going to work for this particular assignment? Yes, right? Similar reason, because SS is going to instantiate G as string. So now top is going to return a string. So string can be assigned to S, which is also a string. So of course this will compile. Okay? Guys kind of got the idea? Okay? So now similarly, this one should be valid or not valid? Not valid, right? Because we are expecting some string from SS.top, but you're assigning a string into an account. Of course, it's not valid. Okay? Similarly, I create kind of symmetric version. If you have SA right now, which is account of stack of account, if you push account into a stack of account, that'll be okay. Right? This line is okay. On the other hand, this line here, if you're trying to push a string into a stack of account, of course it's not good, right? And then if you're trying to assign something from a stack of account, that's okay. That's going to be account. You can assign account to account. That's fine. Of course, you can assign account to string. Any questions? Okay. There will be a tutorial I will ask you to watch. I will include links at the end of the slides. Basically, what you learned before you see generics, the best way you can do to have a very general, very accommodating stack is to have a stack of objects. That's what you would do. However, a stack of objects has its disadvantages, which I would like to delay this discussion here until I talk about inheritance. Okay, but for now, we just want to learn about code reuse. Rather than having a stack of string, a stack of string stack, account stack, we simply have stack of G, right? That's a good thing about code reuse. Okay, that'll be good for now. And now I want to go back to Sa's question about how you can have two generic parameters. It's very easy. I'll sketch the code for you. You will have some exercises later. Okay. Okay, let's sketch that very quickly. Let's say we want to define a class called map. And let's see how you can do that. So the idea about generics, again, is not specific to iPhone. Basically, all the mainstream languages, they support generics. Okay? Maybe the only difference is how you enclose the parameters. In Java, it's angle brackets. In iPhone, it's square brackets. That's maybe the biggest difference. Okay, let's do iPhone. Let's say we have a class called map. Okay? So now I want to parameterize the types for both keys and values. Okay? Let's say I can either put GH, or K and V, like in Java, right? Let's do G and H. And H. And then I can say N over here. Let's do the annotation here. When I say G over here, this is parameterizing the type of keys. H over here, parameterizing the type of values. Okay, that's what we have. Let's see how we can use these. Okay, first of all, let's think about implementation. So we're going to have feature exported to none. Let's say we have a very naive implementation. We simply have two arrays to implement a map, right? We got two arrays, one for keys, the other one for values. The corresponding position for each one of them should make a pair in the map, right? So now let's say we have keys over here, and we also have values over here, okay? Again, because of the uniform access principle, in some way, at this point, we don't have to commit whether they should be attributes or queries, right? So let's say keys, let's just use array. An array of something here, and here will be an array of something here. So what should I put? Well, since I say G is going to be the type for keys, and H is going to be the type for values, right? Okay, let me do a little bit more. Now let's have some queries. So feature here, let's have some, let's say command first. How do I add something into the map? Let's just use put over here. So the IFO convention is we put the value first and then the key. It's pretty much like when you say array put, you put the elements and then the index. In some way, keys are like the indices. Okay? So here we can say some new value over here of type G. Oh, beg your pardon, it should be H. And then we have some new key over here of type G. Okay, I'll draw some correspondence in just a moment. I'll leave the implementation empty. You'll see the tutorial. It shows you how to do it. Let's do another one. Let's do a query. Query, let's say we want to get, given a key, we want to get a corresponding value. So now, any idea what I should put over here? Given a key, I want to return some value. Anybody? So should I put G first or H first? We want to be consistent, right? G. Good. Given a key of type G, return H. Let me just use some color to show you how this looks like. So the green one is the key. Key, key, and key. And let's say the pink one is the value. H, H, and H. Okay, key and value. So we got two parameters. Let's see how we can use this in the client code just to be complete. Okay, I'm going to separate this over here. Okay, let's see how we can do that. Let's say in the client code, again, we have some local variable over here. And then let's say we have M1 for map 1. Let's say we want to have a map which will map from, let's say, just pretty much like an array. Let's say from integer into string. Integer into string. That's map number 1. What about map number 2? For map number 2 here, we're going to say map. Okay, let's say in your student record system at York, it can be your student number into your student record, right? What about just make it, let's say your student number is actually just a string. It might contain some character. Let's put string here. And map to, just a record. Just assume that that's another class. You can see over here, again, we have two different instantiations for key and value. Okay? Now, just a little bit test over here. So now, if I say M1 dot put over here, you can see that over here, since I instantiate G to be integer, and I instantiate the H to be string. So now they should really match, right? So now if I talk about the put feature, right? The put is expecting, I forgot to highlight this way as well. The put is expecting some H. So what is H now? It should be a string, right? The pink one. So this is H. Okay? On the other hand, this is the G. So we should really put the string first rather than integer first. Let me give you something that's wrong. Okay? So for example, if I try this, if I simply put integer, let's say put 2 over here, and then value. Okay, first of all, this one is not going to compile because somehow, you see, you instantiate a G over here to be integer, but you're having, so you're expecting some H over here, right? H is actually a string, but you're having an integer here. So that's not good. Okay, it's a bit tricky. Everybody following? Okay, let's do another one. Let's say why the value here is not good, because first of all, you can see the put feature here, the value, this part here is for the key, and this one should be G, and G here is integer, but this is not integer, so that doesn't compile. Okay, so the position really matters. Of course, the easiest way, you can simply say G and H are both instantiated to integer or both instantiated to a string. You wouldn't have that confusion. Of course, that would be a special case. But for now, you got to be careful. So don't be too surprised. Maybe in the paper exam, I can give you something like this, and then I want you to figure out if something will compile or not. Right? That should be quite a reasonable question. Okay? So now, what should we do? What we should do is, for example, you can say m1.put. And this will be correct. You can say value here, and then integer here. So this will be okay. Okay. As to how you can implement the generic map class in IFO, you follow the tutorial. I got a complete story for you over there. We can go over some details later, but I would say you should really start the tutorial as soon as possible. Okay. Any question about generic parameter before I move on? Are we okay? Clear? Yes. Lab number 2? Not lab number 2, but maybe possibly later. Yeah, but it will be very soon. But you know what? The reason that I need to talk about generic parameter is later on we're going to talk about many design patterns which will have to use generic parameter. And also, when you were doing lab number 1, you were using generic parameter already. Did you notice that? Yeah. Ah, I like that. Let me draw some connection here. So the observation was fantastic. The observation was, this can be some optional exercise for you. It's not required, but I'll just give you some idea. Let's say after Friday, after you submit your projects, there's something you can think about to reflect. What we declare for lab number 1 was like this. We say class array container. Sorry, didn't spell right. Array container. You can see the class itself is not parameterized to any type. Okay? And remember, let's not bother with the feature to none. Let's just say imp, and then we say an array of string. And we have get at. Over there we have I of type integer, let's say int, and then it returns a string. Let's do one command. Let's say insert at over here, and also we have I of type integer, and then we have S of type string. Okay, so that'll be representative enough. Now this array container which you did for lab number 1, you can see the same idea applied. Let me just repeat that. In some way, for the array container, we only worry about how to arrange the order of the elements inside, right? You just want to maybe somehow shift everything to the right when you're trying to insert something. Somehow you don't really care. We never call any feature on the string, do we? We never say the element dot append. the element dot char add. We never did that, right? So somehow the type of the elements in the array container is really not relevant, okay? So what we can do is, first of all, let me highlight the one we can factor out. It's a string, and a string here. What we can do is we can factor out the type of the collection. So what we can do is this. We can say, now let's parameterize the type of the array container to be G. And every occurrence that used to be string can now be replaced by just G. We kind of re-engineer our code, basically, right? So this will be a much better design. So a very good maybe exam or lab test question will be, I give you maybe array container like this, maybe array container of integer. I'd say now, improve this design by making that a generic. How would you do it? Basically, you're going to replace every type about the elements to be G, and then make sure you declare that at the class level. Okay? But that was a very good question. Yeah. Guys, clear? Good. I'm so glad actually I can draw some connection to lab number 1. Okay, if you have no questions, let me see if there's anything else I want to say about generics. And then we can go to the next topic. Question? Yes, of course.
About a map of factors
Yeah.
drugs.
About,
Is it possible to connect the map to another map with the packages like dot? Go back to the slide I was mentioning.
You mean here?
I have a string S, and I do.
you mean this one here?
Yes.
Okay.
So M1 get the copy to M2 put comma
Okay, let me ask you this. Let me try to help you maybe ask the question a little bit easier. So let's say this. Which type do you want to instantiate G into? The key. The key should be what? Integer, and then H? Okay, so we still have a map from integer to string, okay? So now let me just put a new page and then try to see what you're trying to do here.
like the way you said.
Okay, we still have M1 over here. It's a map. It's from integer to string. Okay, yes, what next?
And M2 is that's supposedly a map of student ID to student number.
Okay,
And M2 is a map of student number to student name.
let's say integer. Oh, you're trying to connect them together, right? I see what you mean. I see what you mean. Let's say I see what you mean. Maybe I see what you mean, okay? So you mean this one maybe from student number into student name? Okay, let's say this is student number. And then this is student name.
Okay.
And for map number 2, you want to go from student name into?
From student name into student grade.
I got it. I got you what you mean. Okay, I got what you mean. You do this kind of lookup quite a lot in database. I'm not sure if you took the database course already, but you would do that a lot. Okay, I see exactly what the question is. Let me show. Definitely. So now let's say we got string over here. And then we have, let's say, integer. Let me put real. And this one here is student. I'll give you one example name. And this one is grade. Okay, so let's try to do this on the paper. So basically we got M1 and M2. M1 is a map from student number, let's assume student number is only just as integer, from student number into student name. And then map number 2, M2, is from the student name into their grade, let's say. So now how can we connect them together? First of all, let's see how we can use it. Let's say you can say something like create, let's say M1 dot make empty, let's say. That's something you can certainly define. And also you can create M2 dot make empty. Okay, let's say that. Good. Let me just make some example here. let's say M1 dot put, I forgot my student number when I was at York. It was too long time ago. 1, 2, 3, 4, 5, maybe. Okay, let me put my name here, Jackie. That's for M1, which means Jackie is associated with the student number 1, 2, 3, 4, 5. So now, let's say M2 dot put Jackie here. Let's say some grade, let's say GPA. I'm not sure. Maybe, oh, not that high. I thought the maximum is like a 5, right? Oh, really? Oh, so what do I get? Maybe 6.0 maybe, or 6.5? Yeah, it doesn't matter. It's not real, but anyway, that will make an example. Okay, so now, yeah, go ahead.
I have a question, like in the previous slide, you put the order different for the input, like the input.
It's a very good point. You know, I really don't want to confuse everybody. Let me do it again. He's absolutely right. Here we should put value first and then the, yeah. Let me just do that again. So the value is Jackie here, and then 1, 2, 3, 4, 5 is the student number. And then the real number, which is the grade, let's say 6.5, and then Jackie. So now, let's say we want to look up. Let's say given Jackie, we want to know what his, let's say given a person whose student number is 1, 2, 3, 4, 5, we want to know what his grade is, right? In this case. So now, this is the problem. I'm going to write in red. Given a student whose ID is 1, 2, 3, 4, 5, return their grade. Okay? Now how do we do that? First of all, since we only get a student number to begin with, student ID, which is 1, 2, 3, 4, 5, that's the first input we have. And that kind of match the key for the first map. So we can use the first map to look up what the associated name for that student number is, in which case it will be Jackie. And then we use that name, which we get from the first map, to query about the second map. Given Jackie, what should be his corresponding grade? Okay, let me write it down. So this is what you can do. We're going to use, first of all, I'm going to put it here. I'm going to say the simplest expression you can write would be M1 dot get. Okay, I believe that's get, right? Good. And then 1, 2, 3, 4, 5. And what's the type of this expression here? Should be a string, right? And now we're going to pass this string as an input to map number 2. I'm going to write in green. So M2.get should take this as an input. So that will be how you draw that connection. Let me just write a separate page over here. First of all, when you say M1.get, 1, 2, 3, 4, 5, we know that this is going to return Jackie, a string. We know that a string is exactly the key type for the second map. So we can use that to query about a second map. So we can say that M2.get. Okay? So that's the simplest expression you can get. Okay? So that's maybe answer your question, I guess. Very good. Maybe I will try to make a lab out of this for everybody. Maybe? I'll try. Haven't decided yet what we should do for later labs, but that could be a good idea. Yes?
So I have a question, so the order doesn't matter for the parameters?
The order, okay. It's a very good question. The question was, you guys asked very good questions. The question was, over here we say map is G and H. Does it really matter the order? The answer is no, it doesn't matter. It's really up to the convention for the language. In IFO there, usually when you put G and H, usually the first one means the value, and the second one means the key. In Java, maybe the opposite. But I would say here, as long as you're consistent, you're okay. Because here, I said in the very beginning, G means the key, H means the value. Okay? Now, if I switch the order of G and H over here, it's okay, because I'm still using G and H consistently throughout my code.
Yeah, but my question is like you declared and dot map as integer, comma string, like two parameters.
Over
The
there,
generic type.
you know what?
G is integer.
Then that, you know what? When you instantiate G and H, that the order will matter.
Yeah.
Because it really depends on how you define the order, right? Yeah.
Yeah, like after defining it in
Yeah.
and string.
Yeah.
Like maybe in the last line you said and1 dot put value
Yeah.
and 2, but you are passing in place of integer you are passing value.
I see. So that's why I said this one is not right. So this one is not correct because you're passing 2 and string, which is not right. That's why I put a check cross mark over there.
No, it should be correct for m1 because m1 dot map is integer and string.
So that should be value will be string, right?
Value is
When you declare the M1, you declare this int and string.
But it's put, which is
Yeah, no. Okay, I see what the confusion. Okay. Let's go slowly. Okay, let's go slowly. First of all, guys, okay, it's really important because when you are in the exam, nobody will help you. Let me try to help you. Okay. So first of all, let's say we instantiate. Let's talk about n1. Maybe that was where the confusion is. For n1 here, we're going to instantiate g by integer, right? So now for the put, this means integer should be the second one. And right, you see, you're really going to go step by step. The second one is string, which means the pink one. So which means H is going to be instantiated by a string. Which means the put is going to take a string, which is value, and then the key, which is integer. So that means this is not right.
Oh, now I get it.
Okay, it's okay.
That's the instantiation.
As you can see, the order in some way, when you declare the class level G and H, doesn't really matter the order, but the way you use them, you have to use them consistently. If you just swap the order when you don't really want to swap, you can cause confusion, right? Okay. Any more questions about generic parameter?
In Java,
Uh-huh.
you can limit G to be extended from some library.
Yes, you can. It's called constraint genericity. You do have that in IFO as well. But I will talk about constraint genericity maybe a little bit later. Maybe after we talk about inheritance. Okay? So over here, G and H, we simply say you can replace G by any known class and H as well. But it can be even more expressive later to say G must be a subclass of a particular type. But let's talk about subclass when we talk about inheritance. Let's not worry about this for now. Okay? Okay, any other questions about generics before I move on? Because I really want to talk about singleton. Otherwise, you'll get lost for lab number 2. Okay? For lab number 2, I'm going to release that after lab 1 is due. Either maybe early Sunday morning or maybe Sunday evening. But you can start working on that. And on Wednesday, when you come to the lab session, you get prepared for questions. Right? Okay. I think I have finished all the slides about generic parameter. Let me double check. Okay, but I'll extend the slides a little bit more next week. So let's now talk about singleton. Singleton is quite an interesting thing to have. You can also do the similar thing in Java, okay, by using something called static, right? Something like that. But the way we do in IFO is a little bit. It's also interesting to learn. Okay. Let me open the slides. And then let's go over some slides and I'll show you some demo. We have to really see the critical ideas first before we can talk about a singleton. Okay, so first of all, let's talk about design patterns. So in this course over here, software design. So the most important design idea is design by contracts, which we have been practicing, we'll practice even more throughout the course. But the second thing is, you have to eventually write some code for big projects. And in reality, the problems you're usually dealing with are really not that unique. They may have been solved in a similar way already. So people recommend some good solution to this kind of problem. It's called design pattern. So you can see design patterns, what are they? They are solutions to basically recurring problems, which means problems that occur again and again and again. So we got different patterns for that. So basically, we got some special structure for defining your code in a particular way, so you'll be suitable for solve a particular problem. So however, you should be really careful. We're going to talk about maybe about 5 to 6 design patterns for this course, the most common ones. It doesn't mean that each one of them is a silver bullet. Each one of them is only suitable for a particular situation. So you shouldn't be too surprised. Let's say in the final exam, I give you a problem there. I say, now solve this problem by presenting to me a good design. Over there, you should really think about the design patterns you have learned. Think about under what circumstances is a particular design pattern suitable, right? There's got to be something good about the design pattern. There's also limitation for that, okay? That's the first thing I want to mention before I talk about the first one. Always understand the problem first before, not just because you like a singleton pattern, you should apply singleton pattern to everyone, right? Okay, let's talk about the very first design pattern for this course. It's called singleton. So why do we need singleton pattern? So let's try to see some scenarios over here. Basically, we want to have some shared data. For example, let's say in the bank accounts, the bank account might share some data together among their clients. You may have something like the minimum balance that every client may have, or the maximum balance, or interest rate, or exchange rates. So these are kind of the shared data you have. However, one thing you should note, not necessarily every piece of shared data is applicable to every account or every operation. For example, let's say if I'm doing some local deposit or withdrawal, domestic, do I really need to worry about the interest rate or exchange rate? I don't have to. I only have to worry about the exchange rate if I have to do some foreign transfer or foreign deposit. If I'm only doing domestic deposit, I don't have to worry about exchange rate, right? So there's certain shared data that I don't really care, but there's only certain one I care, okay? Shared data. And as you learn from 2030, if you want to implement some semaphore, you have to have some shared resource, right? So that's a little bit more computer science example. But the more real example is bank account. You have some shared data there. So how do we solve this kind of problem here? So basically every time when you see that the problem requires you to have some centralized resources to be shared among processes or among entities, in that case, singleton pattern will be the way to go, okay? Now, let's say we don't really have the singleton pattern, but we still want to solve the shared data problem. How do we solve it? So this is one possible solution. Let's say we try to use inheritance. So we haven't really introduced inheritance formally yet, but I'll just apply your knowledge back in Java. The idea is really the same. Inheritance here, we talk about the very superficial idea about inheritance, just code reuse. Let's say we have some shared data class over here where we got interest rate, we got exchange rate, we got minimum balance, we got maximum balance, and more. We got lots of shared data, okay? Now, let's say we have different classes in our application domain. We have some deposit, something to do just deposit. We have withdrawal, we have also bank account, and all of them, since it's called shared data, let's just let it inherit from the shared data. As soon as you inherit, you're going to get all the attributes over here in the shared data to be inherited to your class. So which means every deposit has all this information here. Every withdrawal also have all this information here, right? That's inheritance. So that's kind of the first solution here. That'll be naive. However, this is problematic. Can you think of anything that's problematic? Yes.
If you do two separate things at the same time, it might conflict with each other.
Conflict with how? Well, okay. Let's say maybe not conflict. Somehow they wouldn't affect each other, right? Because somehow, okay. Let me show you some idea on the pad, okay? And then I'll take other questions. Give me a moment. Okay, let me just go to iPad again. So now let's talk about the first design, inheritance. Okay, let's say at the runtime, I remember everything is a subclass of the shared data, right? Let's just talk about interest rate, just for that, for simplicity. Let's say at the runtime, I have some deposit objects over here, And if deposit somehow, let's a minimum balance. Let me make that. Let's say this is minimum balance. So this is one of the shared data, right? Let's say at the moment, the shared data is simply minimum balance start to be, let's say 2000, for example. Let's say this is deposit object number 1. Let's say I got another deposit object at the runtime, just separate objects. And because it's also a subclass of shared data, so you should also have something called minimum balance. Let's say to start with, they are both 2000. So now let's say this. If somehow I want to change the minimum balance, it is like a bank policy, bank-wide policy has been changed from 2000 into, let's say, 5000. In this case, how many places do I need to change? One or two? Well, you can see, first of all, the minimum balance over here is actually separate copies, right, among the objects. If you only modify this one here, it would become 5000, let's say. It's not going to affect the separate copy of the other objects. So it's not really going to solve the problem, right? Because you want to say, if the new policy has been imposed, it should be effective for every party that's being affected, right? So this is an issue. So let's say, tell me what the problem is. When minimum balance is changed, we need to change more than one objects. For example, right? So for every object that has the shared data, we have to change them. Otherwise, you get out of sync for the shared data. Questions? Or?
What if it's changed in the shared data specification?
The shared data. But remember, it's inheritance. We are not trying to store it. You see, so here it is a thing. You see the way we do it. I can see where your confusion comes from. If you look at the design over here, we didn't say every class over here has an attribute called shared data. We simply say they inherit from shared data. So they don't really hold a reference to shared data objects. So aliasing doesn't really work over here. Okay? Yeah.
When it's like you have the free permission to that variable.
Yeah, but what read permission is one thing. Yeah.
Write permission.
Write permission. Yeah. Well, the thing is, the issue here is if the global information that's supposed to be shared is changed, it's not really visible to every party that's involved, right? For example, I'll come to your question in just a moment. You can see, especially here. Let's say this is a very simple scenario. Let's say we only got two objects in our runtime. They both share the minimum balance. But if you change the minimum balance, let's say from this deposit's point of view, it's actually useless because the minimum balance it has is only an attribute, which is a separate copy that's inherited to it. So it has no effects on the other one. So it's not going to do. You have to do some global change, which is quite troublesome because you got to keep track of how many runtime objects you have. So that's not.
Okay, you make static.
Huh?
Static.
But there's no static in IFO. Of course, in Java, you may do static, right? But in IFO, it's doing a little bit different way, which is interesting to study. Okay. Questions? Yes. Oh, very good. Okay, good. Okay. Yeah, maybe your response is, why not IFO support static, right? In some way, as soon as you have static, that means you have some global variable, right? If you have global variable over there, that means your language is not itself very OO. OO should be no centralized resources over there, but in IFO, it still keep itself to be completely OO, but we're gonna see a different solution over there. Okay. Okay, that's about some disadvantages for that, but that's the main one. So every time you're trying to update the shared resources, you cannot just modify a single place. You're gonna modify multiple places. Okay, that's the main drawback. Okay, that's kind of the design diagram you should really get used to. Let me just talk about right now, because that's the very first diagram you see. So the diagram you see in lab number 1 is only a single class over there. So starting from lab number 2. In lab number 2, it's kind of, you're gonna, like an exponential growth on the number of classes you have to handle, about 10 or 15, something like that. Okay, so you have to really study the relationship between classes. That's why you need this sign over here. Okay, so let me just talk about diagram here. I may not be able to finish all Singleton, but I'll talk about the main idea first. So you can also go through the slides. I still got 10 minutes. Okay, so now let me just talk about the diagram, because you will certainly need to draw that for your lab number 2. Let me just talk about one by one. First of all, we talk about something called bond, which is called the business-oriented notation. Thank you. Bond, business-oriented notation. I will introduce one by one. Today, let's only talk about 2 things. So there are 2 relationships between classes. So there are 2 kinds of relations between classes. And let me just enumerate them first, and then I'll show you how you can draw them and when you should draw them. First one is called client-supplier, which you're very, very familiar with. Client-supplier. And the second one is parent-child, which is inheritance. Okay, so these are the 2 for now. These are the most common 2. Okay, let's try to understand. It's very easy. Let's talk about number 1. What about client-supplier? Basically, whenever in your class you're trying to make use of the services that are provided by other classes, there's a client-supplier relationship. Okay, let's give you one example. Let's say over here, let's say your, let me just call it account. Class, account, and then, and over here, let's say in the account class I have an attributes. Let's call that owner. Okay, owner here. Owner is of type, let's say, customer. Just that. Basically, whenever you declare some attributes, or you're trying to make use of some other classes, that's client-supplier. Okay, so how do you draw that, basically? Okay, there's a class. The way you draw that is by saying you present the account class over here, and then you also present the customer class over here. Now, in this case, who is the supplier and who is the clients? Supplier. Customer or account? Supplier. Yes. Supplier? Supplier? Account. Oh, really? Yeah, because somehow the account is trying to use some services from the customer, right? Because you declare that to be the attributes. Think about in your array container. Is your array container a client or is array a client? Remember, in your array container class, you declare an attribute imp of type array. In this case, you're trying to use the services from the array class. So the array is a supplier and array container is a client, right? Good. So now, for client supplier, you just draw a double arrow like this. Double arrow. Okay, you can see the diagram also on the slides. Now, and also you will annotate this to say we are trying to say owner, because owner is of type customer. Okay, that's a client-supplier relation. Let's do the inheritance also very quickly. What about for number 2? Number 2 over here. Let's say I have another class called, I would just say, what about students? This one is very easy. So let's say we have a class called students, and okay, this is one class, and let's say I got another class. I have class, I'll say TA. Well, it's a very cliched example, but that will do the illustration. TA, And in Java, you say extends. In iPhone, you say inherits. I think you have used inherits already. Inherits students. So this means we are going to inherit all the attributes and features from the student class into TA. That's what we're doing, right? But how do you draw the diagram? Okay, everything's in the green. So now we call that the student class the superclass or the parent class. Okay, and then it's inherited by the student class TA. That's how you draw. Just the arrow. The arrow is a little bit different. Okay. So we got two kinds of relations between classes. It can be client-supplier, which means you're trying to use the services. Or you can get inheritance, which means you're accumulating the code. Okay, so two. Okay. So we'll see that, we'll mainly see the client-supplier in the Singleton pattern. When we talk about the next pattern, which is called iterator pattern, we'll have inheritance quite a bit. Okay, so now let's see how the Singleton pattern works. Okay, so now let me just, so this is basically, so up to here, so this part here talks about the limitation for the inheritance solution to the sharing problem. So now what do we really want to have as a solution? The solution is kind of interesting because we know that somehow the shared data over there, we want to have a unique access to it so that every time if there's any change to the shared data, it should be visible to every object that's involved, right, automatically. But how do we do that? Okay, so I want to just show you one particular iPhone construct to achieve this. Okay, and let's just read the solution here. We're going to have a separate notion of data and shared access. In the inheritance solution, we have a single class called shared data. In the Singleton pattern, we also have a class called shared data, but we are creating one extra class. The extra class is called shared access. So we kind of encapsulate the shared access to the data in a single class. But there's one construct we need to do this. Okay, let me show you this construct here, and then I will continue from Monday. Okay, let's do this very quickly. Okay, let me just use eStudio, and let me just create a new project. Okay, very quickly, and then I'm going to write some simple tests to show you. I just want to use a simple test to illustrate. Let's say once query. Okay, let's pay attention. So there's a new keyword you have to learn for this Singleton pattern. Okay. So now let me first of all, I'm going to create a new class. Let me call it just class A. Some class A. Okay. So now I'm going to rename this application here. By the way, you can say refactor rename. When you rename, you better say you want to rename the file as well, because file name and class name must be consistent. Let's say test A. Okay, let me just add the EECS library very quickly. And a library here, add library EECS. Include, and OK. OK, let's go back to A. Before I do that, let me just say ES test. And then create make. And then I'll put some tests over here in just a moment. Okay, it's not compiling. And now I'll go to A. Now, I want you to pay attention to what I'm trying to do. First of all, I'm going to have a constructor here. Creates make. So make is the constructor. Constructor is not really the interesting part for this example here. And just do nothing, let's say. A query. Let's say we have something here. Let's say new array. It's going to return an array of, let's say, string. So this is a simple query which always return to you an array. Okay? Let's say we don't really make it too interesting, but we just simply say every time if you call the query here, it's going to return to you the reference of a new array. So creates array of string dot make empty. That's it. Okay. Syntax error, let's see. Dot make empty here. Oh, of course. Result. Okay, so now, any question about this particular query? Nothing new yet. Okay, now I want to go to the test. And first of all, let's verify something here. Test A. Okay, now let's write a test over there. Let's say test. I'm going to make a test query. Add Boolean case over here, agent test. The one thing I'm going to do is very simple. I'm going to first of all declare a local variable of A of type A. Okay, let's compile. Okay, now let's say over here, if I try to do this comparison, result is assigned to A dot make array. It's going to return to me a new array. Agree? It's going to say creates result dot make empty. If I say this, oh, sorry, over here, equal sign over here, and then A dot new array. Okay, let's see, what do I have? Okay, let's just create that. Yeah, absolutely. Creates A dot make, okay, because A can be void. Okay, now, first of all, what this is trying to do is trying to call the same query twice. The first time it's going to create a new array. The second time it's going to create another array, so two arrays. And when you say equal sign IFO, it's going to compare what? It's going to compare the values of the array. It's like an equal in Java, which means you can compare the addresses. Yeah, let's say I want to do equal sign. That's really what I want to do. Let's say if I do this, what's going to be? What's that going to be? False. False, right? Because the first time you call that, it will be a new array. The second time you call that, will be a separate array. So that should be false. Let's double check with that. Okay, let's just run the test, and we expect that to fail. Let me just, okay, bear with me maybe a few minutes. It's really important. Show browser, and then run espec. If I write this, it's going to fail for sure because it's going to be false. Okay, now I can easily make this true. How do I do that? I can go back to A. So this is a new keyword you have to learn. Change it to once. That's a new keyword. What the once would do, if you try to rerun the test, true. Okay, let me just briefly summarize what the once would do, and then we'll continue next time. Give me 1 minute, okay? What the once would do is going to call the query there only once for the very first time. It's going to create a new array. However, any subsequent calls to the same query there, they are not going to create any new array references. They're going to reuse the same reference. That's what the once routine will do. Okay, we're going to use this once routine to solve the singleton problem on Monday. However, I would say when you get lab number 2 on Sunday, possibly Sunday evening, you should really start working on that. So you will see the singleton pattern somewhere in the lab number 2. But don't panic too much. We're going to finish the singleton pattern on Monday. Okay.